Hi everyone, I'm Claire and I used to be in Mr. Horton's Algebra 1 class a couple years ago. So today I'm going to be teaching you a little bit about solving basic equations, otherwise known as linear equations. So there are some main ideas to this and I suggest writing them down because they can help you in the future if you need a refresher or they can just help you remember. So yeah, I suggest writing these down. The first is that the goal of solving an equation is to determine the numerical values of x or value of x. And it doesn't have to be x, it can be any letter like a, b, y, any of those. But usually it'll be x in these kinds of equations. And whatever x is will make the equation true. And for now, here's like a little checklist for solving these kinds of equations. First, you combine like terms. So this chunk right here would be a term. This is a term. So terms that look like this, like they have a number and then a variable next to them, would be clumped together with other ones that look like that. So 3x plus 2x would equal 5x. And then you would do the same for 7, just like you have always done. So if there's a 7 and on the same side there's a 5, you would say 12. That's how you combine like terms. And then the next one is that you collect the variables. So you need to collect them onto one side of the equal sign. And we'll explain a little bit more how you do that later. Yeah, and then you also have to do the same thing with the numbers. And for any solutions that you find, you always have to substitute them back into the equation. We'll also do that later to make sure that it's true. And this is just a way of checking your answers, which is always a great option, always a great decision to do. So now we're going to go over some examples and hopefully things will become more clear. It can be a little confusing at first. So here's our equation that we're going to be solving for x4. First, what we're going to do is combine like terms, and we'll look here. I don't see any terms on this side that also have a coefficient and a variable next to it, the x variable. So there's nothing to combine over here. So I'm just going to leave that be. And same with the 7. I don't see any other lone numbers on this side, so I can't combine anything. And the same case over here. This is technically the same thing as this because the coefficient would be 1. So I don't see anything like that, a coefficient and an x. And I also don't see any other lone numbers over here. So we're going to go on to the next step. And one thing to remember when solving these kinds of equations is that if you do something to one side, you have to do it to the other. Because that's the only way that the equation would stay equal on both sides. So now what we need to do is collect all the variables onto one side. And I see that this is negative. So I don't really feel like making everything on this side more negative. So I'm going to add this one onto this side. And in order to get rid of this on this side, I need to neutralize it. That's how I think of it. So to neutralize it, I need to add x onto this side. So I'm adding x, and like I said, we need to do the same thing to the other side that we did to this side. So we need to add x. And if we add x to this side, we're going to combine like terms. See? And so we're going to combine 3x and x. We're going to combine basically 3x and 1x is how I like to think about it. So that makes 4x plus 7 equals -1 because this says -1. And we neutralize this because when you have negative x plus x, that equals 0. So this side is basically 0 minus 1, which equals -1. And now this side is 4x plus 7 because we added x to 3x. So now we're going to do the same thing with the lone numbers. And how we have to do this, since we want all the x's by themselves, we have to subtract 7 from this side. So we're going to do that by saying -7, And we always have to do it to the other side too. So -7 over here. And then we're going to say 4x equals, because you can kind of think of it as an addition problem. So 7 minus 7 equals 0. So I didn't put anything right there. And then you say -1 minus 7 equals -8. And now what we're going to do is we want the x's to be all alone. So how do we do that? We have to divide x by 4, because this is 4 times x. So we have to divide this by x, and that means we also have to divide the other side by 4, excuse me. So this is, sorry. So we divide this side by 4 as well. And then we're left with, so think of 4x divided by 4 will just equal x, because 4 divided by 4 equals 1. So it's 1 times x. So then we have, so -8 divided by 4 is -2. So that means x equals -2. I would suggest writing that down. I think that'd be useful. And then we can plug this -2 back into the equation to check if it's right. So what I mean by that is that since x equals -2, we can put -2 in everywhere where x is. So we can say 3 times -2, because that's what 3 times x, that's what 3x means. It means 3 times x. So 3 times x, which is -2, so 3 times -2. And then we're going to add 7. And then we're going to say negative times, because this means -1 times x. So -1 times -2. I'm just not putting the 1 there, because when you multiply something by 1, it just equals itself. If that makes sense. So -2. And then -1. So we're just going to solve this. 3 times -2 is -6. -1 times -2 is 2, because a negative times a negative is a positive. And then we're going to subtract 1 from that. And now we're just going to, it's like combining like terms like you would normally do. So -6 plus 7 is 1. And 2 minus 1 is 1. So see, if you get this, that's really awesome. You did a great job. Because that means that it's correct, because 1 equals 1. And if you were to get 1 equals 2 or 1 equals any other number, or just two numbers that don't equal each other, then you know that your answer for x is most likely wrong, or maybe you plugged it in wrong. So then you can check again. And we can do some more examples. So here's our next problem. And we're going to start with combining like terms. So we'll look on this side. Do we see anything that looks like a low number? I do, I see a 5. So then we're going to combine those. So you say, what's 1 plus 5? Well, that's 6. So we rewrite this as 6 minus, or let me backtrack. So we have 6, but do we see any more of these? So we have a coefficient, meaning a number, with a variable, and it has to be x in order to combine with this one. On this side, I don't see any. So I'm going to continue and just write it as it is now. So I'm going to write it as minus 2x. Sorry about that. Okay. Do we see any like terms like this one on this side? So I don't see any. So I'm going to leave that as 4x. And I don't see any like this either, a lone number. So I'm going to leave that as minus 3. Okay, so now we're going to move on to the next step, which is getting all the variables onto one side. So now we are going to look, okay, this is negative. So what I personally like to do is I like to try to get the numbers to be positive. So I'm not going to move this onto this side because it's going to be a bigger negative number. I'm going to move this onto this side so it's a bigger positive number. So what I'm going to do is I'm going to neutralize it, as I like to say. Cancel it out is the better term. So to do that, I'm going to do the opposite of this sign. And in order to make negative 2x equals 0, I have to add 2x. So I'm going to add 2x to this side. And if I do it to one side, I always have to do it to the other. So I'm going to say plus 2x. And that's just, I'm just writing it here because it makes it more clear that I'm saying like equals. Okay, so nothing happened with the 6, so we're going to keep the 6. And these equal 0, so we're just going to leave that. And if you add 2x to this side, this is a like term because it has a coefficient and the same variable. So that's going to turn into 6x. So we're going to write that. And leave the 3 or minus 3 as it is. And now what we want to do is bring this one over to the other side. So in order to do that, to cancel it out, we have to add 3. And always remember, I'm trying to get this drilled in your brain, to do the same thing on both sides. So then we have to add 3 to this side too. Okay. So 6 plus 3 equals 9. And then negative 3 plus 3 equals 0. And 6x stays the same. So we're going to say 9 equals 6x. Okay, and now we have to divide both sides by 6 because we want to get x alone. So yeah, we're going to divide both sides by 6. So this is 9 over 6 equals x. And 9 over 6 simplifies to 3 over 2 because we can divide both of these by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. So this is our answer, 3 over 2. And now we're going to plug it back in to see if it's right. Hopefully it is. So we're going to say 1 minus 2 times 3 over 2. When it's a fraction, it does get a little more complicated, but you can do it. And we're going to try to see if we can do it in our heads. Plus 5. It's 4 times 3 over 2 minus 3. Okay, So the first thing I'm going to do is I'm going to combine 1 and 5. So I'm going to get 6 minus 2 times 3 over 2 equals 4 times 3 over 2 minus 3. Okay, so now we're going to multiply. 6 minus 2 times 3 over 2, which is 6 over 2, which simplifies to 3. And another way you can do this is see that 2 is in the top and 2 is over there. So those just cancel out and you're left with 3. So 6 minus 3 equals, and we're going to do 4 times 3, which equals 12. And then 12 divided by 2 equals 6. So this is 6 minus 3. Actually, we can already see, look, 6 minus 3 equals 6 minus 3. That's true. We can even go further. 6 minus 3 equals 3. And 6 minus 3 equals 3. So that's how we know we're done. Yay, we did it right. So yeah, the ones that come out with fractions, don't think that they're wrong, because they can still definitely be right. And you just have to plug it in to see if it's right. And you may need a calculator sometimes. So now we're going to work on another one. So I'm going to change it up a little bit. So I'm going to ask you to spot the mistake. I'm going to give you a couple seconds, sorry. If that wasn't enough time, that's totally cool. You can just pause the video. But the mistake, let's see. So this one, first, well, let's start from here to here. What did I do? I combined like terms. So 4x plus x equals 5x. And the negative 2 stays the same, or minus 2 stays the same. And then this side is unchanged because there are no like terms. And next I took, I subtracted 2x from each side to cancel this one out and leave this side with all the x's. And that seems to be correct because 5 minus 2, or 5x minus 2x is 3x. And this is canceled out. Oh, I see what I did wrong. I didn't add, so I added, added 2 to this side, but I didn't do anything to this side. And a big rule that I was trying to stress is that you always have to do what you do to the first side to the other side. So since I added 2 to this side, I have to add it to this side. And then I continued, but it was wrong because I did this one wrong. So that's something to stress because it's a big rule. Always do something. If you do it to one side, you have to do it to the other. So that's a big rule. Make sure to always do that. So this is the last practice problem. And you can pause the video to do it now, and I'll show you the answer that I got. And remember to check your answer too. Sorry, this one was actually kind of a trick and I didn't realize it. So sorry to put that on you guys, but it turns out that there is no solution because the x's cancel out. They're the same on both sides. So when I took away 3x from each side, it left me with no x's on either side. And that left me with negative 3 equals negative 5, which isn't true. So that's how you know that the equation has no solutions. So this is kind of a tricky circumstance. Sorry to give that to you, but yeah, so there's no solution. So there's nothing to actually plug into the equation. So you can't see if it's correct by plugging it back in because there's no value for x that we found. So yeah, sorry about that. But that's all for this. I hope it helped you guys. Yeah, and if you ever need help, make sure to ask because it can be super helpful. And I know that algebra is daunting, but it's actually really fun. I actually like it a lot now. but I've been through a couple years of it. So yeah, have some fun. Enjoy Mr. Fortin's class. Bye.